Hi, my name is Anthony, and my designated topic is topic 18, which is polar and rectangular representation of a sine wave. And before I begin talking about what a polar representation and a rectangular representation of a sine wave actually means and what it looks like, it would be first better to understand how a sine wave is produced and how it relates to alternate current generation. So, in AC current power generation, within this example, when a coil is rotated within a magnetic field, depending on the positioning of this coil in that field, there is a varying potential difference, or in other words, varying voltage values. So, as you can see in this diagram, at the point of 0 degrees, looking at the coil in the field, so this is at the point where the coil is intersecting no flux lines, or in other words, no voltage, and this corresponds with the sine graph there. At the point of 90 degrees, the coil is intersecting through the most amount of flux lines, and thus you have a maximum voltage, and this is reflected in the sine graph where you have a maxima at the 90 degree point. Over at 180 degrees, back down to the x-axis, at 270 degrees, you have a maximum in the opposite direction, and then 360 is the same as 0, so you end up back at the x-axis, and that produces a sine curve. Now, in order to understand how polar and rectangular form works, you must understand that a circle can also be used to represent the positions on a sine wave. So as you can see here, pi on 2 on the circle represents the maxima of a sine wave. Half a circle represents half the sine wave. At the position of 3 pi on 2, the sine wave is at a negative maximum. And full rotation of the circle completes the sine wave. Now, as you can see in this animation, as the radius and point travel around the circle, an x and y coordinate follow and produce the same point, and this relates to a rectangular representation. This close-up diagram contains both the polar and rectangular forms, the polar form being comprised of a radius r and angle theta, and a rectangular form containing an x and y coordinate, and these both produce the same point on the circle. Now you can use the rules of Pythagoras to convert between the two and find any unknown values. So using the rules of Pythagoras, to convert from rectangular to polar, you have the equations r equals root of x squared plus y squared, theta equals inverse tan of y on x, and polar to rectangular, you have x equals r cos theta and y equals r sine theta. Thank you for listening.